Today we're going to talk about Newton's third law. So for this, we're going to identify action-reaction pairs. In your text, it gives Newton's third law using these words here. If two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and these two forces are opposite in direction. Now that sounds really confusing that they say it. So we can actually say Newton's third law much more simply, like this. For every action, there's an equal and opposite reaction. These action and reactions are really forces that we are talking about. So let's look at some examples. So here we have a person on Earth, and this is a situation that we're all familiar with, and we know that gravity will pull this person towards the Earth. But what we haven't talked about is actually that person is also pulling the Earth towards them. It's just that the Earth's mass is so much bigger. Here, let's look at this. The mass of the Earth, and we all know this makes sense. The mass of the Earth is much bigger than the mass of a person. So the Earth doesn't move even though a person pulls on the Earth and the Earth pulls on the person. But those forces are equal and opposite. What changes is because the forces are equal, the accelerations are different. You accelerate towards the Earth at 9.8 meters per second squared. But the Earth accelerates towards you at such a small number that we can say it's essentially zero, even though it is not. So this is an action-reaction pair. You pull on the Earth, and the Earth pulls on you. Another example, say you're walking, okay? As you walk, right, in order to move forward, you have to push down onto the floor. And this isn't your force of gravity, because if you're just standing, the force of gravity is pushing. But in order to walk, you have to actually push off the floor to move forward. And when you push off the floor will also then push up on you. So we have these equal and opposite forces again that are happening. So if we write this down, right, you push on the floor, and the floor pushes back on you. Those are the two forces. Now I want to point a couple things out about this situation. Okay. Action-reaction pairs never happen within a free body diagram. They happen between two different objects. So remember, a free body diagram is just one object. Okay? So I want to clarify something here. If we're talking about a box sitting on a floor, we talk about how the force of gravity is pushing on the box, and then we have this force of the floor pushing back up. Those are not, that's a big, huge no. Okay, those are not action-reaction pairs. No, no, no. Okay, because one of them, the floor is pushing up, and the other, the force of gravity is pulling down. The action-reaction pairs in this situation, we've got to think about two different things. Imagine that box is sitting there. I'm just separating them because we have two different things. One, the box is pushing, okay? It's pushing on the floor. And the other force, the floor, pushes back up on the box. Those would be the action-reaction pairs. So it is not within a free body diagram. They're two different objects. And you can always think about it even in terms of a sentence. If I say that the person pushes the box pushes on the person. You just use the same two objects in the sentence and switch them around. So that's the end for action-reaction pairs. go ahead and let me know if you have any questions in class.